Thank you, and good afternoon, Riga. Fantastic to be here. What a show you got going here. So my name is Rowan Hogman. I'm working with Ericsson, and I'm working with research collaborations within Ericsson. Now, what's the big buzz around 5G? Let me offer a perspective on that. If you look at the first G, this was really about getting the possibility to do phone calls wherever you were. The phones were large, chunky, it was analog, sound quality not the best, but hey, phone calls wherever, right? The next G, 2G, the phones got better, digital, smaller, you really got mass market coverage, and this is where the service really took off. In the third G, you got some basic data services. You got the mobile internet. It was not really enough. So with 4G, you got mobile broadband, you got massive video services, and here you're starting to use it for industry as well. And this has been a large, say, journey from 4G. The first 4G is very different from the last advanced 4G, very close to 5G, in fact. So what about 5G? So it's a bit early to say what 5G really will bring us. We're just seeing the beginning of 5G. A good guess is that the higher bandwidth will give us things like augmented reality, super high definition video, and a lot of gaming in there, of course. But more importantly, as I think one of the previous speakers, Ingmar's, was bringing up, the low latency in combination with the opportunity to do massive amount of devices in small areas, in combination with low energy needs, in combination with good safety and reliability, makes it possible for 5G to be a really important technology for both societal applications and industry applications. So we're talking about things like safety for power grids, public transport. We're talking about factories. We're talking about mining, ports, airports, and so on. So, I work with 5G industry collaborations, and what is that? We started already in 2015 reaching out to the industry directly to set up partnerships, because we wanted to understand these different segments of the industries. They're very different from the telecom business that we're in today. So we have to learn about their business models, we have to learn about the languages they speak, we have to learn about their technology, and what our technology really can do and cannot do. And we wanted to show and create showcases for what cellular technology can do with industries. And of course, we also wanted to get some early business and some early positioning that we want to engage with this market. So as of today, we have some 50 industry collaborations covering 5G, industrial IoT, cloud, and AI across the different industries, working with operators, because our model is working through operators in addressing these markets. And we also have a lot of industries, a lot of universities, and also research institutes involved in these projects. So why is wireless and digital transformation so important for manufacturing at this point of time? What better way to think about that than to look at the history of manufacturing and where we are now in the point of time. So if you look back in the mid-19th century, manufacturing was done in small workshops. It was a craftsmanship. And you really couldn't meet all the demand that you have for these goods. So what they did, these workshops, was they tried to limit the variety in the production that they had. They tried to make things more standardized. And this took a large leap forward in 1913. So what happened in 1913? And it's not World War I, because that was 1914. So in 1913, a guy called Henry Ford visited a butchery house. And he noticed that it was these long belts with chickens rolling. And the men were standing on the line doing their specific part of the butchering. And it was really fast. And he got an idea. What if I do this in my car factory? So he started introducing the moving assembly line. And this, of course, became a great success, and a lot of other factories and a lot of other industry took after and implemented the moving assembly line. And of course, with the moving assembly line, you had to further reduce the variety because you couldn't stop the belt and make changes. So therefore, the expression, you can choose whatever color you like as long as it's black, right? Why black, by the way? Japan black was the only color at that time that dried fast enough on the moving assembly line during the 93 minutes that a car was produced. So this continued up until 1955, at which point sales really drastically declined for cars. And the car companies tried to figure out why, why now? And finally, to consumer research, they realized that this depended on that the cars had just become too similar. My car was very similar to the car I bought 2 years ago or 3 years ago, and the neighbor that bought a new car last month, his car is just like my car. So there's no incentive for me to go buy a new car, right? So they started to realize, and this is where the journey started towards customization. They had to do customization, they had to be able to tailor-make the car for a specific needs, and that has continued, and it took a large leap forward, of course, with 94 and the introduction of internet, because now, all of a sudden, you could type in your own request straight into the manufacturing and get whatever products you like. In fact, today, you can order your own Converse shoes to have them exactly the way you want them. And when you order a car today, well, of course, then you give your exact details on how you want the car to look like, the interior, the wheels, and all that. Now, looking at this, why am I spending so much time on this? What's wrong with this image from a manufacturing point of view, do you think? So, moving up this curve here, you're limiting the variety and you're getting up the volume, so you're achieving economies of scale, right? You can reach new consumers, and the cost of your product is going down. Large volume, low cost, that makes sense. Here, something happens, right? Because now you have smaller batches, and you're not getting that much more paid for these products that you're producing here. So, you have a problem with profitability. It's difficult to continue to be profitable in this kind of market. And this is where operations technology from the industry, communications technology from telecoms, and IT technology has to come together to find new and smart ways of manufacturing to be able to stay profitable going ahead. And this is what the German industry, with the German government, coined as Industry 4.0, really to continue to make their industry successful going ahead. And this has spread all across the world. So, looking at us, Ericsson, I know the previous speaker talked about networks that were successful outside of China and Europe and US and Korea and so on. We make a lot of those networks. We have 25 live 5G networks across the world. We have more than 80 commercial agreements right now. But that's not what I'm going to talk about, really. I'm coming at this from a different angle, because we, Ericsson, we make a lot of base stations, we make a lot of antennas. So, of course, we are a large manufacturer ourselves. So we realize that a lot is needed in the factory to make it even more efficient in this day and time. So we eat our own dog food, so to say. We got a factory in China, we got a large factory in India, we got a factory in Brazil, we're building one in the US, we've one in Sweden, and we've got one in Estonia, which is not really far from here. So looking at the Estonian factory, this is a prototype factory, one of our smaller ones, but it still has 2,000 employees. And here we introduce about 100 products every quarter. Now, with 100 new products every quarter, we have to rearrange the production line all the time. We have to have really smart things in there. So we're heading towards having some 11,000 connected devices in there. One of the things we have is these automatic guided vehicles that will take the spare parts exactly to the right place and take the products as they have been built to the next station and so on. These we can easily kind of reprogram to suit the changing layout in the factory. That's flexibility that we're using. This we're using 4G for instance. Now, one that I'd like to spend a little bit more time on is something we call augmented reality troubleshooting of circuit boards. When the circuit board doesn't pass the quality control, we look at it and we try to figure out what's wrong with it. Now, this normally means that we have to go through like 80 pages of PDF to understand the components, what you're looking at, and so on. Now, what we did was we actually put a pad, or we could use Google's, or we could use a terminal, and we can get these instructions as to what you're seeing, what you need to test, and also you could get help remotely as to how to do this and what you need to check and so on if you can't find a fault. Now, this is really successful. It can really reduce the time that you need to spend, which means that you can do more boards. You can do boards that you otherwise would have had to throw away, so you're reducing scrap, you're saving environment, you're also boosting, of course, your own financials. One thing that we had a problem with here is actually zooming, because some of the chips that we're using, they're smaller than 1 millimeter in diameter. So that's one thing for you guys, startup smart people here. If we can figure out a way of zooming and using augmented reality is something that we really need. Another thing that we really need here is also being able to translate between our product database of components and our AR tool to merge those together, because it takes a lot of time to put in what each component is called in the AR tool. So that kind of integration is something that we're looking for as well in AR. So leaving that and going more into a value chain. And here I've chosen a mini value chain to give you some sense of the kind of things that we're engaged in. And looking at this and thinking about getting raw material, in this case then metal, taking that metal, working with it in a factory, and then producing a product, and then taking it to shipping. Now, this could be trucks, this could be ships, this could be airplanes and airports. In this case, I've chosen ports, which is one of the things that we're working with, and I thought we'd walk through this. So starting with the mine, how many of you have actually been in a mine? Can we have a raise of hands? We have some people here that have been in mines. That's great. So you guys know then that in a mine, typically somewhere like 300 to 600 meters under the ground, you have like tens of kilometers of tunnels. It's a huge place. It's pretty dark. You're dependent on good air, of course. You have to ventilate and so on. Once per day, at least, you do blasting in the mine. And this is to get new materials to work with, of course. When you do the blasting, you have to move people out of the mine. Then you do the blasting, and then you ventilate out the air, because there's a lot of poisonous gases that gets released. There's also a lot of dust that goes in there. So you have to wait. You have to ventilate out all the gases, all the air. Then you move the people down again into the mine, and then you continue the production. Now, as you can understand, this is like a 2 to 3 hour process each time you blast. And you blast at least once per day. So if you instead could use remote machines in the mine and control these remotely using a cellular network, you could free up a lot of production time, right? You could start the production straight after the blast, or even standing a bit away from the blast during the actual blast. This is something that we have in operation. We've tried this. It's good for several reasons, not only for the productivity that increases, but also think about the operator here. Now, this operator, instead of sitting in the mine in the machine, he can sit in a nice control room, have his coffee machine, have his colleagues, he can discuss, he can take a break, very easily go outside, get some fresh air and so on, come back. It's a much more pleasant way of working, not unlike, if you think about it, the kind of gaming that our kids are doing at home, right? So you can see this future. Today it's quite hard to find new operators. There's a lack of operators. And this way, an operator could work with several mines at the same time, right? So depending on the machine, he could also shift machines very easily. Now this goes not only for mines. If you think about it, it's for forestry, it's for agriculture, it's for construction sites. So those are a lot of the different industries that we're looking into and working with as well. Now, if you think about the mine, now this kind of remote management makes the case for working in the mine. And as I think some of the previous speakers said, you don't need to wait for 5G. This already works with 4G. You just get so much better with 5G as well. Once you have the remote management in place and the cellular network in place, you can start exploring a whole bunch of other applications as well. Think about, for instance, these rock bolts that you have in the mine. So you have these long 3-meter rock bolts that you shoot into the walls in the rock bolt, and this is really to make sure that the shaft doesn't cave in. Now, as you know, you guys have been in a mine, it's a dangerous environment. You have movement in the mountain, and it happens that these shafts cave in anyway. So think about startups and what you can do. A small company in Sweden called ThingWave has actually put sensors on these rock bolts. So you can actually measure and detect when there is movement in the mountain, and you get an early warning so you can evacuate the mine. Then you have things like gas detection, you have things like automating the ventilation on, off, and so on. To do that optimally, you don't want to use unnecessary amount of energy for this. Automated transports, just a basic thing as being able to make a basic phone call down in the mine, which you aren't today if you don't have a connected mine. So a lot of stuff going on in mines. Let's look at connected factories. Now, the case I've chosen to bring up here is about producing turbine blades for aircraft engines. These are quite sophisticated production elements. You actually mill these out of a solid block of titanium, thinking about the titanium now that you bring from the mine. So this is a process that takes 12 to 60 hours. And after this is done, not all of these pass the quality control. In fact, about 25% of these turbine blades have to be thrown away because there are minor defects. I mean, if you think about it, this is going into an aircraft engine. It has to be 100% correct. So what we did here is we actually placed a sensor on the block, the titanium block that is being milled into this product. And we could measure and detect automatically when there was some sort of vibration that didn't feel correct. We stopped the process, we made adjustments. That way we produced these without faults, or at least we could reduce the number of faults to minimum. And of course, this is a lot of savings in not only metal, but also work and also energy. But also one really interesting thing with this is that these ready turbine blades, they were so exact. So when in operation in the aircraft engine, they also drew less fuel. So we saved on carbon emissions by implementing this. This is one case. There's plenty of cases in manufacturing. I mean, if you think about it, it's optimizing the whole production. Today, it's not at all digital. Getting it all into a digital process, being able to change faults across the whole chain of production, being able to detect faults and correct them. Working with digital twins where you can take the whole production process offline, optimize it, make sure that you got it really good, then press the button and it goes into production. You have things like safety alarm, automatic alarms for the temperature, the air quality. You have things like better tools for the workers, thinking about AR equipment, thinking about exoskeletons where you become more precise, thinking about 360 vision to be able to see behind your back and so on. All these things are things that will help the productivity in the factory. So, moving into the last case that I have to show with you, which is the ports. Now, thinking about the port business is very much a business of really moving things really quickly through the port. Quick offloading of the containers, quick onloading of the containers, and to minimize the time for all of this. Why? Because ships and crews are really expensive in operation. So an hour's delay in this really means that you would lose about $100,000. So what we did here in the case of ports is that we connected HD cameras on these mobile cranes in the port of Qingdao, which is the 7th largest port in the world, number 4 in China. These HD cameras and the information that they provide could help this crane to actually automatically hook onto the container. This way, the whole lifting and offloading could be automized, and working together with self-automated vehicles in the harbor using the same cellular network, you can create a full system of automation in this harbor, being able to move people out of this really dangerous equation with large cranes, large containers, and so on. So here you could save on the labor cost and make this a fully automated operation. This was the port of Qingdao, but we've already done this much closer to us in the port of Rotterdam, which today is a fully automated port. It's the 4th largest port in the world. And of course, here you see a lot of interesting cases as well. Apart from the actual offloading, think about group communication between the people that you still have to have there. Think about the asset tracking. Think about the emergency takeover of vehicles. Think about things like video surveillance, but also drone inspection in the places where that are really difficult to access. I think with all these cases that I've shown you today, they are still immature when it comes to the whole ecosystem. And this is something that the previous speaker was bringing up as well. There's so many opportunities in there. I mean, we as a network provider, together with our operator, we can bring a well-functioning cellular network into these spaces to really provide the underlying technology. But then there's so many opportunities in terms of really getting these thousands of sensors in place, getting them integrated with products, integrating the technologies that already are existing here. So there's many, many opportunities. Also thinking about the security. I mean, these manufacturing companies are really keen on the security of the data, and they don't want to let the data off the floor. But if you think about it, in order to do AI, in order to compare and improve the processes, you have to kind of accumulate the data. So savvy people in software and IP can really do a lot in terms of solutions and security solutions for manufacturing as well. And the last area that I would like to mention is also the integration. If you think about it, manufacturing companies and industries as a whole, they have a lack of IT savvy people that can bring together different kinds of solutions that are needed and integrate them into something that works for this factory, maintain them as well. Thank you very much for listening. I really enjoyed presenting to you. Thank you.